Hello, welcome back. This is Calculus by Dr. Oz. So we're going to have another application of definite integration. It's finding the arc length of the curve, and the given curve in this problem is y equals ln of cosine x, and we're going to consider the length of the curve corresponding to the interval 0 and pi over 3. And first, we're going to write a definite integral that represents the arc length of the graph, and hopefully we're going to be able to evaluate that. And at the end, we're going to use the integrating capabilities of a graphing utility to approximate the arc length. Okay, so before we get started, I want to quickly go through the definition of the arc length. And in fact, these are the formulas that we're going to use along the way. We have two different versions of that. In one version, you have the function provided to you as a function of x, so y equals f of x. So as you see, the integration becomes the integral depends on just x, so we have dx correspondingly. And in the second formula, we have the function provided to us as a function of y. So x equals g of y is the function representation. And as you see that this integral totally depends on dy. So depending on how the function is provided to us, in fact, the function here is defined as a function of x. So that means we're going to use the very first formula here, the top formula, to find the arc length. And also, let me just give you the graph as a heads up for you to see what we're talking about. So we're talking about the curve here, as you see, between 0 and pi over 3. And we're going to try to find the arc length s of that. And I'm going to graph this again for the rest of the video, and we will do all the calculations together. Have your graphing calculator ready, and let's hit the road. All right, let's start by sketching the graph of the function y equals ln of cosine x. Please have your graphing calculator ready and plot the function ln of cosine x for x min to be 0, x max to be pi over 3. And you can pause the video right now, and I'm going to show you the graph in a second. Okay, so please match your view of the graph with mine. Okay, so I also plotted this for the interval negative pi over 3 and pi over 3 just to see what the full graph is, but I only need the part corresponding to 0 and pi over 3. Okay, so I only need, I don't need this part, right? But I only need this part. So essentially, the question is asking for the arc length, which is, I'm going to denote it by lowercase s, okay? So if this was a string, right, you just straight that out and then try measuring it all the way. This is exactly what the question is asking, but we're going to find the length of the rope by using an integral formula. So for that reason, I want to take you back to the definition of the arc length. And there are two formulas, and what you should stare at this point is how the function is provided to you, how the curve, the equation for the curve is provided to you. If it is provided to you as y equals f of x, go ahead and use this formula to find the arc length. Okay, let's say like you have the interval a b, and the arc length is the integral from a to b. 1 plus the derivative of the function squared, and then we have the radical sign, right, dx, okay? So all we need is the derivative of the function to be able to write down this formula. And the next thing is to evaluate the definite integral. And if the graph, or if the function is given by the equation x equals g of y, so the function is written in terms of y, then the formula changes, okay? And then you have to write down the integration formula in terms of dy, okay? So essentially, this part becomes 1 plus the derivative of the function with respect to y squared and the radical sign. And the integral is from the lower limit c to the upper limit d, okay? So what do we have in our case? Well, in our case, we have the function given as ln cosine x. So this is in fact y equals f of x type representation of the curve. So then I'm going to use this formula to evaluate the arc length. Okay, so let's go ahead and evaluate the arc length by writing that s, lowercase s, is equal to integral from 0 to pi over 3, I need 1 plus f prime of x squared dx. So let's say like this is our f of x. And at this moment, go ahead and find f prime of x, okay, by using the derivatives formula card. So you have the ln of u, and you want to take the derivative of ln of u for u equals cosine x. The derivative is u prime over u, and this is minus sine x over cosine x. But by using the definition of sine x over cosine x, that's in fact the definition of tan, right? So it's minus tangent x, okay? So we can go ahead and plug this back in here, okay? So integral from 0 to pi over 3, 1 plus negative tangent x squared dx. All right, so let's like expand that out. In fact, write it in a cleaner way. Integral from 0 to pi over 3, 1 plus tan squared x dx, okay? All right, so, well, we don't have any formula to directly integrate this function, the integrand here, but we can use an identity that we learned earlier, and it's called a Pythagorean identity for secant and tan. Let me just put that right here, okay, because that's what I'm going to use right here on the left bottom corner. So 1 plus tan squared x is equal to secant squared x, okay? This is the alternate version of the original Pythagorean identity, which is cosine squared plus sine squared x equals 1, okay? So I'm using the alternate version of that, okay? So let's just sort of like use it. So you have radical secant squared x, and you have the radical of the perfect square of secant, so that should be equal to secant x only. Okay, and go ahead and use your basic integration formula card because you have the formula for the integral of secant x, or antiderivative of secant x. That's what we need to be able to use the first fundamental theorem of calculus here. So that is ln absolute value secant x plus tangent x from 0 to pi over 3. Okay. So far, I think we are done with part 1 and part B as well, because in part 2, I'm sorry, not part A and B, but part 1 and part 2. So in part 2, we are asked to write a definite integral, right? Definite integral that represents the arc length of the graph. We did, in fact, we evaluated that. Okay. So right now we're going to use the first fundamental theorem of calculus to evaluate that integral, but we need an approximate value, so you're going to use your calculator at the end. So let me just write with another color here. So I'm going to plug in the upper limit. So that is ln of the absolute value, secant pi over 3 plus tan pi over 3, minus ln of secant 0 plus tan 0 in the absolute value, okay? And go ahead and use your calculator and try to get an approximation, and you should be able to get, at the end, let me just write down the exact value here, which is ln the absolute value 2 plus radical 3, but that's positive. So ln of 2 plus radical 3, okay? And that is approximately equal to, okay? Or maybe I can just write it here, okay? Let me just continue from here. That is approximately equal to 1.317. Okay? So this is the arc length of the curve ln of cosine x for the piece in between 0 and pi over 3. Okay? Again, if this was a rope, let's say clamped at origin, okay, clamped at the origin, right, and it's sort of like bent, right. So if you want to put it like all the way flat, or if you straight that up, right. So the length of that is going to be exactly 1.317. Okay. All right, so that's the end of the video. Thanks for watching. I'll see you in another video. Bye.